going to look inside the contents of the GEM-19T Magnetometer / Gradiometer system. So we're already familiar with the main console unit. What we haven't seen before is the battery charger. So when there is power applied to the battery charger, it's going to go green. There's a little LED indicator on here, and there's a fast charge system. It turns orange when it's charging. When it's not charging, it just is not lit. It goes to 120 volt power, system power to your home or shop, and then converts it to 12 volt DC on this Canon plug, which goes into the RS-232/power port. Okay, so the batteries are internal, rechargeable, and if we need to change them, we have to send it to GEM, which is the manufacturer, for service, or their service depot in BC. We have the instruction manual, a copy of which you will find in Moodle, the version 7 manual, which is the firmware version of all of the NATE systems. You've already seen this. This is the 5-pin, or sorry, the 6-pin Canon plug to 9-pin serial or COM adapter, RS-232 port, communication port. We have a harness system. So you can see that the console is in this webbing, and this harness system will allow me to put it on my body so I could look at the display and manipulate it. And of course we have the sensors. So the sensors are somewhat the same, except one is meant to go always in the bottom position, but both sensors can be placed in the top position. So again, as we've seen before, this one has a larger sort of polyplastic extension of the housing around it, where I could screw in one of the extension poles, and of course that has to be on the bottom. It cannot be on the top, because here on the second one there's nothing to screw into the top to. It always has to go on the bottom. So best practice in magnetometer mode is going to be to run this one. Again, it's filled with kerosene. You hear it? Have this on the top of the poles. I'm just going to take them out of the box for now, out of the transport case. Again, these are weatherproof, so you could run this in ice and snow and rain, and it's not going to be any difference. So we have 5 poles, non-magnetic, so they are aluminum. They're light, but they're strong, with a thread, male on one end and the female on another. 4 of them are exactly the same to give us some extension off the ground, and the last one actually has a bit of a bevel on it, or a point where it's going to rest on the ground surface. So these screw in, or they thread in quite easily. I'm going to hook all 5 of these together, and I'm going to put one sensor on the top to run it in magnetometer mode. So again, if I was running a gradiometer, perhaps I could put the lowermost sensor right here, or I could put it in between here, depending on what your survey parameters are. And then I will put the sensor here on the top. So we have my long pole. It's going off the screen, and then running in magnetometer mode. We're going to take the 4-pin Canon plug, and it's keyed. It could only go in one way. We're going to put it in the lower sensor port. Okay, we're running a gradiometer. We're going to have 2 sensors, and obviously an upper and lower as required. So I'm going to stop this video. I'm going to put the harness on, and then you'll see me doing some surveying within my backyard. Okay, so I'm going to walk a quick survey along my backyard. Just from the apple tree towards the camera, roughly the line is north to south. I'm going to use a station spacing of 1.5 meters, which is my pace, or my stride length. I've set up this metal table and chairs here on the lawn, so as I transverse along my line, we should be able to see the magnetometer pick up this metal table and chairs. Keep in mind, this is a very sensitive instrument, and I have a patio set here, a metal fireplace, metal chairs, there's rebar in the concrete. I have my home, I have my garage, all sorts of interference, but we may be able to see a slight deflection with this table and chairs. I'm going to start on the north side, and I'm going to initialize the unit. It's going to do a quick auto tune, and then I'm going to take a station that's going to be my base station. So afterwards, my very last point, we're going to revisit to see if we have any drift. Now the drift should be marginal because this is going to be an approximately 5-minute magnetometer survey. I'm going off camera. Start here by the apple tree. So I hit A to start the file. It's doing initiation. It's doing a auto tuning. It says please wait on the display. And now I could go ahead and hit any key to start the survey. A will take me back to the main menu. And the reason why they do this, if you're working in the bush or the swamp or in the Arctic, you don't have to fumble finding the exact 16 keys here. You can just basically hit down on the keypad. As long as you avoid the A, then you're going to be taking the reading. So this is going to be our first station. It's also going to be our base station. I'll go ahead and get a reading, and I'll shut it up. Takes around 4 seconds, because that's the cycle time. 56,292.4 nanoteslas. Again, I suspect that a lot of that is because I'm right next to a trampoline with rebar in the concrete. We'll see what happens if I get an increase as I go towards the table and chair. I'm also going to take a repeat station. And it says number 1, take a repeat at the same position. And this will also show up on the data file. So we're going to go ahead and do that. So our line is 1S. I just called it line number 1, and this is station 0 right side. Okay, I took another measurement at the exact same point, 56,263.66. So it's a slight change, increase of 1.26 nanoteslas. Seems reasonable. So I have 2 data points on that station. I'm going to go ahead. Again, that's the base station or the first station. Walk my stride, and then take another reading. It's about 1.5 meters. Simply just click the button. This is station 1.5 south. Magnetic field intensity has decreased. It's now 56,266.58. So it decreased minus 27.08 nanoteslas from the previous reading. Go ahead and take another reading. At a new station. Click the button. $56,233.12. Again, it's still fairly high. I have lots of sources of metal here, but again, it did see a slight decrease from the previous point. Now let's go and see what happens as I get right above this table on my next point, right here. Do I have a slight increase or not? Yes, I do. It has gone up 56.05 nanoteslas, so my overall total magnetic field is 56,289.17. Okay, so I'm just going to get around here. We'll just estimate where my next point would be, somewhere here. Another reading. You want to try to keep the pull as straight up and down as you can. Try to keep it as still as you can. So now we've gone away from the table, we've seen a decrease of now to 56,127.77 nanoteslas. So it dropped minus 161.4 nanoteslas in a short distance. Let's carry on. $56,010.74, so 56010.74. It's dropping. 55,973.77 nanoteslas. We'll do one more. $55,992.96. Okay, now I'm closer to my furnace on the inside of my garage, on the outside of my garage, rebar in the concrete, my garage, my house, everything. Okay, so now before I end this survey, I'm going to go back to my base station, my original station, and get one more point, or just a repeat point. So this last point was 10.5 south. So in the data file, this is going to show up as 12.0 south. But in fact, I have moved. There's no GPS in here, so I'm going to have to keep track of that in my field notes. So my base station was previously right here. The time is recorded in the unit. We had set the time previously. We'll take two readings. $56,296.85. That's essentially what it was when we started the survey. There's basically no change in the magnetic field in such a short period of time. We need some hours, or at least 20-30 minutes to elapse before we'll notice a huge change. We'll take one more reading. The repeat reading changed by 0.77 nanoteslas, 56,297.62. Okay, so that's the end of our reconfigure the device. Right here, I'll add in the second sensor, and we will do a gradiometer survey. The end of the magnetometer survey was that. And we'll start a new data file. Okay, so this video is actually the next day. It was difficult to take a picture of the GSM screen while operating it. So just to give you an idea of what it looks like when we're acquiring data, again from the main menu, and again this is a different data file. We're just going to hit A, and then we're going to hit A to start. So first thing it's doing an auto tuning. I tried to do this inside the home. There was too much magnetization, too much potential magnetization within the structure of the home, so I had to come outside again. It's always difficult to film these LCD screens outside. Anyway, it's doing an auto tune of the device, and now it has passed. So just disregard the station intervals. That's an artifact of yesterday, although for you it will be seamless. So I'm just going to go, it says A for the main menu, which we don't want to do, we're already in the reading menu, or another key to read, or one to repeat the same station. So again, as I was saying, you don't want to have to fumble around with these keys when you're out in the field, so I just hit another key, like 6 for example, and you can see I have those cursors. It's actually taking a reading. So the total magnetic field now, again, we're only hooked up to the lower sensor, 56,453.66. Okay, so that negative 58.06, that's deviation from the last reading. Again, if I want to repeat that same reading, I just hit 1 at the same position. It'll let me take it again. So you'll notice that this value won't increment. This station position won't increment for next reading. And it's complete. Okay, this value up here, this 78, this is a quality control indicator that's explained in the manual. Basically, when it exceeds a certain value, it says you have suspect data or you have a lot of external interference. You can also see our voltage of the unit too. When you're in the field, you want to make sure that's greater than 11.2 would be my recommendation. So you go. We want to take another reading. We'll see next time the station increment will go up by 1.5. That was my pace when I previously set this up. The line position will change, will not change. And I just here this time I hit the number 3 key. Now the value should be fairly close because, full disclosure, the sensor is just lying on the ground in my grass, 3 feet away from me. So there shouldn't be any significant reason, why we have a dramatic change in the magnetic field intensity. So notice here that the station has increased to 24. If I want to go ahead, 24 north, if I want to go ahead and just take another reading, maybe this time I'll hit the 9 button. Again, it's taking its reading while the cursors are inverted, and you'll see the position go up to 25.5. So again, in total magnetic field, all that you are recording, or what it's recording that you'll be plotting, is going to be this, the total magnetic field intensity. Okay, now you can see that the unit has been configured differently. The two sensors are apart. This is a value that we'll have to measure. We have to put this into the software to make sure it knows what the geometry is. Okay. And so let's go ahead and start the Gradiometer survey, see what we get repeating the exact same process as before. Back at my base station. New file, new data file. It's doing the auto tune. Started reading at 00. Line 1 S, station 0 south. Running through its cycle. 56,276.2 nanoteslas is the total magnetic field. The gradient between the two, the change is 157.32 nanoteslas. Just going to take one more measurement reading as a repeat. So hit number 1 for repeat. The gradient is now 156.98. It's essentially the same. Go ahead and take one pace. One stride length. Run through another cycle. Try to keep the pole as stationary as possible. Gradient is 113.32 nanoteslas. Again, what I'm looking for here is the gradient value. That's what I'll be plotting eventually. Next station. .65 nanoteslas per meter. Almost right on top of it again. Negative 42.62. Okay, so again, there is an anomalous reading, a negative value in the magnetic field intensity change. Again, looking at the overall gradient, looking for anomalies. Oh, next station right here. Jump back up, 218.48. So I had a fairly interesting anomaly, and then it dropped down. When we got to the table and chairs, now it's increasing again. So that is, means that there's something different going on. Loosely interpreted. Okay, 443. Now again, we're getting so much interference. The gradiometer reading is drastically affected by surface readings, and that's what it's really used for. Almost for like environmental geophysics. Now we have the hose and everything else, so it's going to be very difficult to survey, but we'll continue. Do a couple more. Okay, 463. Again, the value is increasing once I hit the back of my garage, but nothing like the dip that we saw when we crossed the table and chairs. 440.63. So we don't have to do a drift calculation. I don't have to revisit the base station because I don't care about the change in magnetic field. I'm only looking at a drift over time between the two units. or drift between the two units at a certain location. Okay, this is what the Gradiometer screen is going to look like. You can see I've reconfigured the tool for Gradiometer. The rest of the settings look similar. So I want to hit A to start. It's going to do an auto tune routine the very first time. Tries to take the first measurement. So I have two sensors connected, one to the upper, one to the lower 4-pin port. Okay, and there's no indication of a failure. Everything looked good. So again, I'm going to go ahead and just hit any key to take a station, much like we did for the magnetometer. Now you're going to see the display is going to change. We're going to have our total magnetic field, and we don't have a deviation between the last reading. We have a differentiation between the upper and the lower sensor. So we have a difference in magnetic field of 71.55 nanoteslas per meter between the two sensors. Again, I could go ahead and take a repeat reading by hit 1. Again, these sensors are just lying on my grass. They're about a meter apart behind me. But you can tell there is a differentiation in the magnetic field. One is actually right next to my deck, and one is about a foot off further into the grass. So again, take some more readings. So it is interesting that you can actually get the total magnetic field intensity, which is also something that you could plot, of course. But we're also in this Radiometer survey, what we'd really probably be interested, well, you'd plot both, but you're going to get that differentiation in nanoteslas per meter between the two devices, assuming that you know what the spacing is of the sensors. So again, if I want to go back to the main menu or end the survey, I definitely can just by hitting the 1 and the C. A couple other features worth knowing. If we were to dump this data to a computer, we'd have to go into C info, and we go first of all what files are in the unit. Right now I said there's 50 files that can be stored. We go D for directory, and it shows you all the different files. So those were the default names, .m for magnetometer and .g for gradiometer. Hit F to forward, cycle through, and you can see more files. There's quite a larger one with 105 readings. File 15, it's a magnetometer file. And here's the one, the files that we did here from my backyard. Unfortunately, to get out of this menu, I have to hit 1 and C to go back to the main menu. There's no back from here. And then if we wanted to initiate a data transfer, we'd go into info, and then we go into BRS232, and we have to set up the configuration for the handshake. So this is fairly old school data transfer techniques back from last 30-40 years. But anyways, 8 N and 1, 8 data bits, no parity, and 1 stop bit. Basically, N at 600 baud per second. When you're sending data from this unit to a PC, you want to make sure that the receiving PC also has the same settings, the serial port settings. That way they're basically talking the same language. So for example, that's typically a default. You can make it faster if you wanted to, but honestly, we don't have that much data in here. And you can also have it real-time dumped to a computer, which I have set to no because we have plenty of memory in here in our case. And I could go ahead and then I could actually start and initiate a dump, a request. Okay, so I'm just going to hit 1C. I'm not going to do that right now because we're outside and I don't have a PC with those capabilities of a serial port right now. So let's go back to the main menu.